this is an iHeart podcast. Guaranteed human.
With no fees or minimums on checking accounts, it's no wonder the Capital One bank guy is so passionate about banking with Capital One. If he were here, he wouldn't just tell you about no fees or minimums. He'd also talk about how most Capital One cafes are open 7 days a week to assist with your banking needs. Yep, even on weekends. It's pretty much all he talks about, in a good way. What's in your wallet? Terms apply. See CapitalOne.com/bank. Capital One, N.A., member FDIC.
In Orlando, meetings reach another level thanks to a growing list of award-winning restaurants, a world-class convention center, a great hotel community, easy access through the airport, and of course, the weather. Andrew Moyes, VP of Fan Expo HQ, had this to say about Orlando. Luxury hotels, Michelin restaurants, easy access through the airport, all of those key things feed into the proper executive experience. And while you may know Orlando for its attractions, industries like healthcare, aerospace, and advanced manufacturing make it a hub for cutting-edge businesses. And that's what makes Orlando unbelievably real. Learn more at orlandoforbusiness.com.
Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark, and there's Star Child Chuck Bryant, and there's Moonrock Jerry Rowland over there. And I'm just plain old Josh Clark, like I said. But this is the Galactic Federation of Stuff You Should Know episode of all time.
There's my tall boy.
Yeah, there you go. Chuck likes to get nice and loaded when he talks about space stuff.
Here's something that I found helpful for me that I think might help other dum-dums like me.
You're not a dum-dum.
I like that shirt, by the way. You look like a circus peanut.
It is circus peanut colored. Oh, my God.
That is circus peanut orange.
100%, dude.
I want to squeeze you.
Do not.
All right.
All right, you can squeeze me.
You ready for this? So if our solar system, which is the sun and its orbiting planets, moons, dust, gas, a lot of dust and gas, rocks.
Our solar system.
Yeah.
Yeah.
If that was, let's say if the sun was the size of a grain of sand, then relatively our solar system would be like the size of our hand with that at the center.
Wow.
And then if you extrapolate that, then our hand in relation to the Milky Way galaxy, it would stretch the width of the United States.
Wow.
And
love stuff like that. Oh, keep going, Chuck.
Well, that's just one of, billions of galaxies in the universe.
Right.
If you go solar system, galaxy, universe.
And then so the universe would be like the United States and Canada.
Well, and I am a dummy because I was like, and so let's stand in Lebanon, Kansas, because that's the geographic center.
Not as far as I recognize.
Well, but we're not at the geographic center of our solar system is not the geographic center of the galaxy, though, so I was wrong.
No, there's a long history. By the way, it was beautiful. I love that.
Thank you.
There's a long history of assuming that we are at the center of the universe. Yeah. And then there's an almost equally long history of science proving that no, we're absolutely not. And we finally figured out that we're about a quarter of the way between the galactic center and the edge of the Milky Way.
Yeah.
And that
checks out.
So we're nowhere near the center of the Milky Way.
Well, no, because the center of the Milky Way is a supermassive black hole.
The universe itself is expanding, and it's expanding faster than the speed of light. And galaxies are just caught up in the motion, going through the motions.
Yeah.
And we're just here on this little rock called Earth trying to figure out what in the H is going on.
Yeah, during our, 80 to 90 years here.
Yeah.
We're so insignificant.
Luckily, though, we figured out how to encapsulate knowledge in the form of writing, so later generations can build on the work of earlier generations, because we'd be toast if it all just got reset after everybody's lifetime and you couldn't say, oh, I've learned all this stuff.
Yeah.
People just keep discovering the same things, which would be great for that sense of discovery, but it wouldn't really help move our species forward.
No, and that's what we're all about here.
That's right.
Right?
Yeah.
Us and the hubs. So as far as what we know about galaxies now compared to the very beginnings of this study, of course the Greeks were looking up at the sky a long time before we were. and they came up with this name, Galaxies Kuklos, and it means Milky Circle.
Yeah, and guess which word we kept to describe galaxies? The Milky.
Not Kuklos?
So when you're saying, like, look at that galaxy up there, you're saying, look at that Milky up there.
Oh, right.
Kuklos is circle.
Yeah.
I looked it up. I'm like, surely Kuklos is the Milky one, but nope.
No, it is surprising.
But the Greeks were like, it looks like a Milky Circle, so we'll just go with that.
Yeah, and they were on to some, like, kind of like everything they were doing back then. Some stuff they got wrong and were kind of ahead of their time in their thinking, and other stuff they weren't quite right about because of technology.
Right.
But Galileo he looked up and it's like, hey, there's a bunch of stars up there.
It ain't milk.
Congregating for a reason. Yeah.
And so we knew pretty early on that, like, we were in the midst of some sort of group of stars.
Yeah.
But for most of the era, where we were looking up at the sky, at least in the West, I'm not sure about like the Muslim world. I know that they kind of had their own like track of astronomy and mathematics that was in many points in history far more advanced than what the West was at.
Yeah.
But as far as the West is concerned, they didn't understand that this group was anything less than the universe itself. They just looked out and they're like, well, there's the universe. Everything we're seeing is the universe, and that's all that there is. Mm-hmm. Not that we possibly lived in what were later called by a guy named, I think, Charles Messier, who called them island universes.
Yeah.
No, I'm sorry. It was Harlow Shapley in the early 20th century. He started looking at some of these things and realized that they had the same structure that the Milky Way did. We had kind of identified that we were in our own little galaxy, but that other stuff was beyond our own little galaxy and that they were their own galaxies.
Right.
And so these island universes came to be called Milkies.
Yeah. And so did you pronounce them Shapley?
Yeah, there's a E that's not supposed to be in there.
Oh, really? Because no one wants to be called Harlow Shapley, I'm sure. So he was actually right in this argument, right? This longstanding sort of not disagreement, but debate with Messier.
No, Messier was a couple hundred years before him.
Well, but no, the whole argument, though, I mean, they didn't literally argue with each other.
Because Messier was able to encapsulate his ideas in the form of writing.
Yeah, but they had a longstanding, again, not personal beef, but debate. Because we didn't have the technology to prove one or the other correct until Hubbs came along. And in 1924, he basically said that Shapley was correct.
Yeah, that these little island universes weren't in the Milky Way. They were way far outside of the Milky Way, and the universe was astoundingly bigger than we thought, we previously imagined.
So we mentioned Hubbs, Dr. Hubble, and his awesome telescope.
Right.
Which, did you know that's being replaced? I mean, I don't think they're going to like destroy it, but
surely not.
It's being, well, I guess sort of replaced by the James Webb Space Telescope.
How do you mean being replaced? Like they're just going to shoot it out of the sky with a space laser?
Well, no, that's what I was saying. I doubt if they'll destroy it, but there's a new guy on the block.
Right. Oh, yeah.
And
everybody's hot and heavy for him.
And his name is the James Webb Telescope.
Yes.
Which will be, I think now it's been pushed back to 2021.
Yeah.
But this thing will supposedly be able to observe like the formation of galaxies.
Pretty much. The Hubble telescope as it stands right now shows us, I think, back to like 400 million years after the Big Bang.
Not bad.
Which is astoundingly early in the universe's development. And the whole point of astronomy is what they're doing is looking back in time, right?
Yeah.
The further away some object in the sky is, what you're seeing then is what that object looked like, say, 1 billion or 2 billion or 10 billion years ago.
Yeah.
And so you can take the structure of that object and compare it to objects that are much younger that we know of today that are closer. And you can see how the universe has evolved, and we can learn, figure out some of the mysteries of the universe, like where it came from, what its structure is, that
how
kind
we're
of
all
stuff,
going to die.
Right? So if Hubble that's great. Great end of the world reference, by the way. If Hubble can see back to 400 million years after the Big Bang, supposedly James Webb Telescope can see back to like 200 million years.
Oh, really?
And that is a hair's breadth
Sure.
from the origin of the universe.
So close.
Yeah. So it's the big guy in town, the new sheriff.
Yeah, I just don't want Hubbs to get kicked to the curb.
The James Webb Telescope is going to mush his face out of the way.
Wait, you didn't say the James Woods Telescope.
He would. He'd be like Trump forever.
The telescope full of right-wing rage.
Yeah. And very smart. I think he has the highest IQ of anyone in Hollywood.
Really?
Mm-hmm.
He's
like
a smart
160 something.
What did you know that he supposedly tried to thwart the 9/11 hijacking?
No. What?
I think I need to look this up. I'm speaking from the top of my head,
All right.
but I'm pretty sure that it is fact that he was on a flight with one of the ringleaders and was like, this guy's on my flight and he's taking notes and something's fishy here and I'm going to report it.
Really?
And that ended up being, like Muhammad Atta or something.
Wow.
I got to look that up because I'm truly like
Wow.
flying by the seat of my pants. But I think that's a true thing.
He also made an appearance on The Simpsons once.
He was also the best part of the Stephen King anthology film Cat's Eye.
I don't remember his.
As the man who tried to quit smoking.
Oh, Critters, Inc.
Is that what it was called?
Mm-hmm.
Yeah. You remember that?
Sure.
That was him.
I don't remember James Woods being that.
I think he was the guy that was trying to quit smoking under threat of violence to his family.
Right.
Remember that?
Yeah, that was a great
I
one.
haven't seen that in a while. I'm going to have to check that out.
Okay.
I'm sure it's being rebooted.
Boy, we are stalling.
All right. That's because it's space. All right. So the various shapes, 1936, Edwin the Hubs Hubble classified these in his Hubble sequence as elliptical, spiral, and irregular. Elliptical, I mean, we'll go into detail on these, but about 60% of all galaxies are elliptical.
Yeah.
Roughly 20% or so are spiral, which is us. And then anywhere from 1 to 20, 25% are irregular.
Yes.
But elliptical there's a range of shape from circular, which is E0, all the way up to E7, which is the most elliptical.
Pretty much, yeah. And you're like, okay, great. So all you need is elliptical. That's all galaxies are. But no, there's also something called spiral. And even though Hubble classified them by their shape, it's really, they're more differentiated by their features.
Yeah,
and how
spiral's bright.
Right. They're bright. They have stars, bright stars, lots of hot gas.
Yeah.
They tend to have arms that stretch out from them.
Yeah, like if you've looked at pictures of the Milky Way galaxy, it looks like what does it look like? Like someone spinning an octopus.
A bit of a whirlpool.
Sure.
Someone spinning an octopus. I love that.
Yeah.
That was perfect. I wish that's what the Greeks had come up with instead of a Milky Way.
I'm surprised they didn't.
Although all they saw was like a strip of white light. No one had any idea what the Milky Way looked like until the 20th century.
Yeah, that's true.
So all right, I'll ease off the Greeks, everybody. I'm sorry.
So, but spiral are the brightest, right?
They're the brightest because they have the most bright stars.
Right.
Elliptical tend to sometimes not have any bright stars at all. And then the other big difference between them is that elliptical are disordered and chaotic, whereas spiral are much more orderly, where everything in the galaxy rotates in orbit around the galaxy center in the exact same way and for the exact same reasons that Earth rotates around the sun. Except in this rotation, our solar system takes about 230 million years to make it all the way around the Milky Way rather than 1 year around the sun.
Yeah, that's a big diff.
Yeah, it is.
And again, with the size, as illustrated at the onset, that might make a little more sense.
Sure.
The grain of sand in the palm, that palm in the middle of the United States.
Yeah, it's
actually, let's say the United States was, that would place us like, I don't know, what, Kentucky?
What, the center of the U.S.?
No. If the center of the U.S. is Lebanon, Kansas.
Not in my book.
What is in your book?
I'll tell you later.
Okay.
I've got my own opinions on that.
Just no credit to Lebanon, Kansas. I get it. I think it's actually a couple of miles from there. But
See?
I don't know where that would put us. If we're in like a third of the way between the edge and
I see what you're saying.
If Lebanon, Kansas is the middle and
it's not though, but let's just for the sake of argument suppose it is.
And the east coast edge would be the outer edge. Where would that put us?
Yeah, I think Kentucky's probably a pretty good
roughly
Kentucky or maybe East Tennessee.
Okay.
Or Middle Tennessee, something like that. Yeah, somewhere between.
Just not Memphis.
No.
Then the spirals are broken down and subdivided into other categories. Normal spiral.
Mm-hmm.
That's where that's sort of the classic disc shape that we're thinking of, right?
Yeah, that's the other feature that they have is like a hump. They look like a UFO.
A bulge.
If you looked at a spiral galaxy from the side, especially I guess an SA, I think an SA.
Yeah, that's the largest nuclear bulge.
Right.
Nuclear bulges.
So it's like...
Great band name.
It really is. But the bulge is like, it's got a hump on the top and a hump on the bottom and then a disc of stuff in the middle.
Yes.
Like a UFO. That's what it looks like.
Yeah.
That's a classic spiral galaxy.
Right, which would be the normal. Then there are the barred spiral. That has a disc shape as well with a bright center as well. I don't get the difference then visually.
So I think the difference is the disc shape is with the barred spiral, the center of it is drawn out.
Oh, okay.
So like in a normal spiral, it's just a nice circle in the center, a nice tidy sphere in the center. Whereas in a barred spiral, that sphere is pulled out into an elliptical itself. So it's like a bar of light going through, the middle of the galaxy, and that's the galactic center nucleus.
All right. And then we have our irregular as the third type of galaxy shape. And these are very faint, very small. No bright center, no spiral arms, just,
losers.
Sort of the loser of the
loser
three.
Galaxies. So they used to think that this was the evolution of galaxies, that the different galaxies was like...
Oh, really?
Either it started as elliptical and then moved to spiral or most likely vice versa. Now we found that's not the case at all.
Interesting.
They think probably... galaxies tend to start out as spiral galaxies, the ordered kind where everything's just going around nice and easy. And that the reason we have elliptical galaxies, the disordered kind, is because a spiral merged with another spiral, which we'll get into later.
Yeah, the collisions of galaxies.
Yeah, which I honestly didn't know that much about until this episode.
Yeah, and it sounds a lot scarier than it is.
It's really not that scary, so don't be scared, everybody. Right. You probably wouldn't even notice. You just have an extra sun 5 billion years from now.
I feel like we should take a break.
I think we should too. We made it through page 1.
All right, we'll come back with page 2 right after this.
Learning things with Chuck and Chuck. Learning all the things, stuff you should know.
All cat parents understand the feeling of being ignored by your cat and often asking yourself, does my cat even love me? And there is only one solution to solve that, Sheba. Feed your cat Sheba and go from feeling ignored to truly adored in 12 days guaranteed or your money back. Sheba has a menu of products, appetizers, entrees, treats, and even a kitten's menu. So Sheba has a product for even the pickiest eater, like the Sheba Puree, which is made with bone broth. It's a protein-rich, lickable treat with chef-inspired flavors. It has a smooth and creamy texture that cats love. Plus, it supports a strong bond between pet parents and their cats with a hand-fed cat treat. It also contains no corn, wheat, soy, or artificial flavors. So instead of feeling ignored, you're suddenly the center of their world. It's basically a fast pass to favorite human status. Next time you're wondering if your cat loves you, grab Sheba Puree or explore their entire range of textures and flavors at your local retailer. To learn more, check out Sheba.com.
Spectrum Business keeps businesses of all sizes connected seamlessly with fast, reliable internet, advanced Wi-Fi, phone, TV, and mobile services.
That's right. And Spectrum Business offers 100% U.S.-based customer support 24/7 to help you stay up and running. And they offer tailored connectivity solutions with packages built for your business budget.
Yeah, so it's no wonder millions of business owners rely on Spectrum Business to keep them connected. Visit spectrum.com/business to learn more. Restrictions apply. Services not available in all areas. All right, Chuck. So we're talking spiral galaxies because that's what we care about, because that's what the Milky Way is.
That's right.
It's a spiral bar galaxy, to be particular. And so it's got that center hump, the galactic disk. And the galactic disk is actually made up of a few different parts, too. You got the nucleus, which is the center.
Mm-hmm.
You've got the bulge, which you love, the nuclear bulge.
We've said bulge like 9 times already.
And then the spiral arms. These are like accumulations of stars, gas, dust, all sorts of stuff, planets, solar systems, all that.
And that's where we are.
Right. We're in a spiral arm.
Yeah.
Now, the Milky Way has 4 spiral arms, 2 major and 2 minor, and we're in a minor one, Orion, which is still, it's fine. We're in a minor arm, but it's the Orion arm, which makes it pretty cool.
Right. So I guess it would not have been an octopus spinning. That would be 8 arms.
Well, maybe we haven't discovered the other 4 yet.
Yes. Or maybe we're just a ceiling fan.
Maybe so. I like the spinning octopus
Yeah?
the most.
We need to get some more arms then.
You know, you shouldn't eat octopus. They're extraordinarily intelligent. Just FYI.
I think we've sung our octopus praises
Okay.
over the years.
But are you eating them, though, still, is what I'm saying.
No, I don't eat octopus.
Okay.
They,
Me either.
Yeah?
Mhm.
Did you give them up after our episode on it? Or
Yeah, around that time.
is it okay to eat squid ink pasta, though?
Squid, they're stupid. Who cares about squid? I'll eat them all day long. Luckily, that's what most calamari is squid.
Or not even, right?
What is it then?
Isn't there like a big calamari hoax going on?
I can believe it. Some of that stuff is awfully rubbery.
Yeah, I think that's the deal. All right, so back to the shape of the galactic disk. There's also the globular cluster.
Mm-hmm.
These are above and below that disk. And then the halo, which is hot gas, we think. And that is that sort of dim region that you see around the galaxy.
Right. And when you think of like the Milky Way from all the pictures you've ever seen, what you're mostly thinking about is the galactic disk. The globular clusters, nobody really thinks much about, but they're actually old, super burned out ancient clumps of stars that formed in like the early galaxy that used up a bunch of stars, used up their fuel really quickly. And now they're just kind of like these dead balls that are in orbit around our galaxy. And we actually can use them and the effect that our galaxy has on them, the tidal effects of gravity, to figure out how much mass our galaxy has.
Yeah, and, gravity is what's holding all of this together. And you would think when you see something like the Milky Way galaxy, and gravity is dependent upon mass, that center would be where all the mass is. But that's not the case. It's a little bit opposite of what you might think.
Yeah, that outer halo has about as much mass as the intergalactic disk, too.
Yeah.
The
Kind
thing
of counterintuitive.
Yeah. And because that halo is made up mostly of gas and some dust, it's actually orbiting or rotating at a different rate or different velocity, I guess, than the galactic disk.
Right.
So there's actually torque that gets produced because the galactic disk is like dragging it along.
Is that what makes the arms?
No, we found out recently, like within the last month or two, I believe, that the actual Milky Way galaxy is bent on the ends, like an S.
Okay.
So it looks like an S from the side, kind of like a sombrero with like the front up and the back down.
Okay.
That's what the Milky Way is. Not
Yeah.
an octopus, not a ceiling fan. It's a crumpled sombrero. Maybe a nacho sombrero, like the one Homer Simpson wore.
Right, or the guys that just wear the cowboy hat with the front brim turned up, like the cook at the cowboy camp.
Sure, Cookie.
Yeah, Cookie the cook. Yeah, and galaxies are very, very far apart from one another. The closest one to us, Andromeda, is 2.2 million light years away from us.
Yes.
And that's relatively close in the grand scheme.
Right.
But that's also pretty far apart.
So there's this Professor Barbara Ryden from Ohio State whose lecture we came across, and she like just nails this, right?
Yeah.
2.2 million light years is an astoundingly large distance, right? But it's actually really close for a galaxy because galaxies are so huge. And the way that she put it, like if you took a pair of ping pongs.
All right, here we go.
And said one was...
Ping pong balls?
Ping pong balls,
Okay.
yes. No, games of ping pong. If you took two games, if you took 2 ping pong balls and one was the sun and one was a neighboring star to the sun, Alpha Centauri.
Okay.
And you put them relative to one another.
Okay.
The ping pong balls would be as far apart as Columbus, Ohio and Jacksonville, Florida.
Okay.
If you use ping pong balls to be Andromeda and the Milky Way,
here we go.
the distance would be 3 feet.
Oh,
relative to one another.
interesting.
It is interesting.
Yeah.
It's at least as interesting as your grain of sand in the palm of your hand.
I like it. That's less than one Big Mac.
Maybe I didn't get it across. Let me try another take, okay?
No, I thought it was great.
Okay.
They use, we should talk about parsecs a little bit just because of the Star Wars thing. Because a parsec is a unit of distance that is 3.26 light years.
Okay.
And you remember in Star Wars, the famous line from Han Solo, remember?
No.
That he made the Kessel Run in 12 parsecs. So as a young, dumb kid, I thought that meant, like a parsec was like 30 seconds.
Right.
So he did this thing in a matter of minutes.
Right.
And then when I learned that it was a unit of distance and not time, I think a lot of people's inclination would be that would be a mistake on the part of the writer of Star Wars.
All right.
But Star Wars nerds are quick to point out that no. He did mean a unit of distance, but he actually skirted very close to a black hole on his Kessel Run, and he actually shortened the normally 18 parsec route to 12 parsecs.
Wow, that's a big shortcut.
So he basically took a shortcut.
Right.
Yeah.
Not bad.
Yeah, I'm just kind of wondering, this is, all after the fact. And they were like, oh, I thought it was.
It's called shoehorning, I think.
Yeah, I think so. They got a lot going for them.
Yeah.
So as far as formation of the galaxy, again, we're talking about going back further than we can see with our current telescopes, even the Webb one upcoming. But we do have some pretty good guesses that after the Big Bang, about 14 billion years ago, is when these galaxies formed from, again, just dust and gas.
Right. There was
collapsing.
lots of hydrogen gas in the early universe.
And helium. Yeah.
Yes. And so from this expansion that took place, there were parts of the universe that were less dense than other parts, and the denser parts slowed down the expansion enough for some of this dust and gas to accumulate into balls, which went one of two ways. Either those balls formed the earliest stars, and then those stars started to accumulate into a galaxy, which to me doesn't make sense, because if stars are so far apart, how would they have any effect on one another to form a galaxy? Probably not that. Instead, they think that the clouds of dust and gas formed like what's called a proto-galaxy. And then from that, more and more density was created, more and more gravity pushed more and more dust and gas together to form stars within this accumulation, which would be kind of like that disk, the gas disk that's flowing around the Milky Way.
Yeah, and it's interesting. It just seems like so much happened because of collapsing in on themselves.
Gravity.
Yeah.
Yep.
Really interesting.
It really is. I mean, and this is the whole reason why people study this stuff, is like when you start to understand this, you can start to understand the very structure of the universe. And they've actually started to map this to where they can see where the dark matter is. Remember in that episode that they started to map dark matter in the universe?
Yeah.
And then also physical matter. And the map that they're created, it looks like a cobweb. There's lots of like spindly parts and thick clumps, and then parts where there's voids, and it looks unsettlingly like a close-up of brain tissue, of like neurons in a brain.
Yeah,
with
these
what the universe looks like.
Voids in between areas of matter. Really interesting stuff.
Yeah.
So we were talking about the distance between galaxies being really large, and that is true, but also, like you said, at the same time, galaxies themselves are so large that they do collide. I mean, should we go ahead and talk about that?
I think it's inevitable.
But when they do collide, it's not like everything within that galaxy is so far apart. It's not like what you might picture in your head, which is planets and stars just smashing into each other all over the place.
Right, which you would think so, but the distances between stars are so colossal that entire galaxies can just merge with one another without any star collisions, or virtually none.
Now, do they always merge, or do sometimes they just kind of pass through one another and come out the other side?
I think they can do both.
A little different.
There's definitely types of universes that pass within
Galaxies?
Yes.
Yeah.
Yeah. That's all we're talking about right here, right now.
Mm-hmm.
The galaxies pass close enough to one another, but don't necessarily merge. But their gravity still has an effect on one another.
Right.
There's a pair of galaxies called the Mice, where they've gotten close enough together that they've pulled stars toward one another, and they each have tails now.
Oh.
There's a galaxy called the Cartwheel Galaxy that a smaller galaxy passed through and apparently created ripples. So just like, as Professor Ryden put it, just like you drop a stone into a pond, it creates ripples in the water. That other galaxy created ripples in this larger host universe. So there's other things that can happen besides just a straight up merger. But I think even in a merger, sometimes some of the stars shake loose and end up just they're out in space.
Yeah, that makes sense.
Yeah.
And when they do come together or collide, spiral galaxies generally, like the shape can change, and they generally go to the elliptical side. So if you see a spiral galaxy like our own Milky Way, then chances are it has never been in such a collision.
Yeah. They think that the spiral galaxies used to dominate. I think you said like 60% of galaxies today are the elliptical ones, right? The disordered ones.
Yeah.
And they think that spiral galaxies used to be the majority, but so many of them merged to become elliptical galaxies. That's what we see the most of now.
Yeah, what do they say? About 50% of all galaxies at some point have been involved in a collision.
Yeah, I saw as high as 90% in one place.
And the Milky Way will at some point, right?
Yeah.
I mean, it's kind of inevitable, isn't it?
We're going to merge with Andromeda in about 5 billion years. In about 3 billion years, we'll start affecting one another at the edges. We'll start pulling one another into each other, and then we'll eventually merge and become one, called the Milkomeda galaxy.
Is that really what it's going to be called?
Yeah. Hopefully within 5 billion years, they'll come up with a better name.
Interesting.
Andromaxy.
Yeah.
Andromiway.
The Androma way.
Androma way.
That's
I like
pretty good.
Yeah.
The Andro way.
It's definitely better than the Milkomeda.
Yeah. But, I mean, we're not going to be around. Our show will be.
I don't know. It's possible.
What if this lived on billions of years from now?
That's what we're doing, right? That's what we're hoping for.
So these galaxies throughout the universe do exist in galactic clusters. They are drawn to one another by gravity. And we are in what's called a Poor cluster, which is less than 1,000.
Well, like way less.
Yeah, called the local group. And there's only 50 of us.
That's a good local band name, too.
I think so. It sounds like a sort of a union group.
Yeah. Or like
the local 41 or whatever.
If you're just playing for free beer, that's what you're doing with your band.
Local group.
The local group should be the name of your band. That's a great name for it.
That's pretty good. And then there are rich clusters, and there are more than 1,000 in the rich clusters.
Right. And some have way more than 1,000. There's one called the Virgo supercluster that has 2,500 of these of galaxies all clustered together.
Wow.
So think about it. You've got planets orbiting a star, solar system. Solar system is orbiting the center of the galaxy.
Mm-hmm.
Galaxies can orbit one another.
Yeah.
Or at least have effects on one another's orbits. Everything clusters together in larger and larger amounts thanks to gravity. Once you pass a certain threshold, and electromagnetism and the strong and weak nuclear force are not like the dominant forces, gravity takes over and it does some interesting stuff to the structure. And it's driving astronomers batty. They're like, surely there is some rhyme or reason to this. There's some pattern to this.
Yeah.
There's got to be. They're like Jim Carrey in the number 23 or something, you know? And they think that if they can study the evolution of galaxies, they will be able to figure out the process that happens.
Yeah.
Or what the ultimate point will be.
Are we done?
Let's take a break.
Oh, no, we got more?
Yeah, we got more.
All right.
Learning things with Chuck and Chuck. Learning all the things. Stuff you should know.
All Cat cat parents understand the feeling of being ignored by your cat and often asking yourself, does my cat even love me? And there is only one solution to solve that, Sheba. Feed your cat Sheba and go from feeling ignored to truly adored in 12 days guaranteed or your money back. Sheba has a menu of products, appetizers, entrees, treats, and even a kittens menu. So Sheba has a product for even the pickiest eater, like the Sheba puree, which is made with bone broth. It's a protein-rich, lickable treat with chef-inspired flavors. It has a smooth and creamy texture that cats love. Plus, it supports a strong bond between pet parents and their cats with a hand-fed cat treat. It also contains no corn, wheat, soy, or artificial flavors. So instead of feeling ignored, you're suddenly the center of their world. It's basically a fast pass to favorite human status. Next time you're wondering if your cat loves you, grab Sheba puree or explore their entire range of textures and flavors at your local retailer. To learn more, check out Sheba.com.
Spectrum Business keeps businesses of all sizes connected seamlessly with fast, reliable internet, advanced Wi-Fi, phone, TV, and mobile services.
That's right. And Spectrum Business offers 100% U.S.-based customer support 24/7 to help you stay up and running. And they offer tailored connectivity solutions with packages built for your business budget.
Yeah, so it's no wonder millions of business owners rely on Spectrum Business to keep them connected. Visit spectrum.com/business to learn more. Restrictions apply. Services not available in all areas.
All right, so we've talked a lot about the distance between galaxies, but there's actually a name for that space in between galaxies and these clusters that we talked about called the intergalactic medium. And it is not empty. It's not just some void. And we don't know exactly what's going on in there, but we're studying it a lot. They think that there's probably some gas because I think that's their default for everything in space.
Right, there's gas in there.
Like, there's got to be some gas in there and probably some dust.
And a lot of it's super cold like you would expect.
Yeah, this is what the strange thing is, though, but some of it is really, really hot.
Right.
And have they explained that yet?
No.
No?
No.
They're just taking a stab.
It's a really neat age of discovery for astronomy. Like, we're getting better and better at looking out into the universe.
Yeah.
So we're finding out more and more, but just because we get data back doesn't mean we can necessarily make heads or tails of it.
Yeah, that's true.
But yeah, there's hot sections of the interstellar void. What's it called?
Intergalactic medium.
The intergalactic medium.
Yeah.
And
which is kind of an interstellar void.
Sure. But I can't start making up astronomy terms. I need to use the real ones. But there's also, like, in these hot pockets, right? There's some pepperoni and cheese in there that will take the roof clean off of your mouth.
Oh.
There's hot metals, which would also burn the roof of your mouth too, at 1,000,000 degrees Kelvin.
Yeah, and I mean, that is the difference too, from the cold intergalactic medium, about 2 degrees Kelvin, all the way to millions of degrees.
Yeah.
That's quite a span.
Right. And no idea why, or what it's doing there, or what's going to become of it, or if it used to be something else. We just don't understand if it follows a pattern, and it seems to.
Yeah, for sure. And thanks to Hubble, too, we also have Hubble's law.
Yeah.
It's so hard to believe he was doing all this in the 1920s.
Dude, I know. He was a boss.
Yeah, like really, really, that's amazing.
He also once beat up James Webb in a bar fight, which makes this whole telescope thing really ironic.
But Hubble's law states this observation that he made way back when, and this is an actual graph of this relationship, but he basically was like, you know what? Everything is moving away from us. Like, every time I look at something through this telescope, everything is moving away. And not only that, but the further away it is, the faster it's moving away.
Which is mind-boggling.
Yeah.
Because you can think like, all right, the universe is expanding, so that's fine. Everything's moving away from us. Mm-hmm. It also suggests that there's no center to the universe. This is where that comes from. Because everything, no matter what direction you look in, it's moving away from us. You would think that...
But doesn't that mean we're the center?
Bite your tongue. But that's the cosmological principle, that everything is expanding, the entire universe. Not everything in the universe is expanding within the universe.
Right.
The very universe itself is expanding, right? And since some things are moving away, the further they are away, the faster they're moving away from us. Mm-hmm. That means that there's plenty of the universe that we can never possibly detect. Because even if we get up to the speed of light for travel, some parts of the universe, the furthest away parts, are actually spreading at faster than the speed of light.
Yeah, we can't catch up to it.
So it is cosmically impossible for us to ever detect a large part of the universe, which is why when we're talking about the universe that we're talking about and observing, that's called the visible universe.
Right.
But that's probably just a relatively small chunk of the universe itself, which might be infinite for all we know.
Yeah.
And we may never know what the universe is really shaped like, what it's made of, how big it is, because of this expansion that's actually speeding up and accelerating beyond our ability to detect it.
Amazing.
It's kind of sad in a way.
Yeah.
And eventually, this is the most mind-blowing thing I've ever heard. The expansion will accelerate so much that the moon will no longer be visible to us. Like nothing will be visible to us.
Right.
And on a long enough time scale, I believe you wouldn't even be able to detect your hand in front of your face if it was physically possible, because of that expansion of light.
Wow.
Right?
Yeah.
So the universe expanding is actually pulling light out of the visible spectrum into a longer wavelength in what's called red shifting, because the red is the longer wavelength end of the visible spectrum.
Right.
And so what Hubble detected is called the red shift. Everything's moving away from us.
Yeah, which we could observe because of X-rays, right?
Because of infrared, I think.
Oh, infrared?
Yeah.
Man.
I know. I love this stuff.
I'm glad you do.
I'm aroused.
Oh, goodness. So I guess if you're aroused, we should talk about active galaxies because,
I'm still waiting on my squeeze, by the way.
Oh, your peanut squeeze?
Mm-hmm.
All right. Just hang on.
Okay.
That's your little treat if we finish this.
Okay. If we finish this.
So if you're looking at a normal galaxy, let's say like the Milky Way, I guess, all this light or most of it that you're seeing is pretty evenly distributed throughout that galaxy, because it says, those same galaxies that have the even distribution of light, they have looked at it through X-ray and ultraviolet and infrared, and it seems like they are giving off that energy from the nucleus, and that is the active galaxy. Okay, yeah. Which is a very small percentage of the overall galaxy.
Right, so the light and energy in a normal galaxy, a non-active galaxy, it's distributed evenly throughout, whereas in an active galaxy, all of that light and energy is coming from the center.
Yeah, but what are those, like how many percent? I was going to say 1%. I don't know if that's right.
I'm not sure what the percentage is. I know they're fairly rare from what we can tell.
Yeah, actually, I didn't have a percentage, but it just says a very small percentage.
Yeah, I think they've discovered like a couple thousand so far, or less than 500,000, less than 1 million, which is a very small amount.
Yeah.
But the distinction between them and a regular galaxy is, again, all of that light, all of that energy is coming from a very small portion of the galaxy.
Yeah.
Rather than the galaxy as a whole putting out all this light and energy, it's all concentrated in the middle.
Right.
It's very weird. And upon closer inspection, these things that look as bright as, galaxies that are relatively close to us, we're finding are actually billions and billions and billions of light years away from us. But they seem just as bright, which makes them super energetic.
Yeah.
So they've started to try to figure out what's going on. And they think that the culprit are supermassive black holes at the center of these galaxies.
Well, and that's what is at the center of our own.
I suspect there's a supermassive black hole at the center of every galaxy. That's my big prediction for the third decade of the 21st century. We're going to figure that out. Okay.
If you're talking active galaxies, there are 4 classifications within that genre. And they say that if it's basically, it may not be structural. It might depend more on like the angle that we're viewing these things.
Yeah, like they're all probably the same thing.
Right. Yeah. But for that classification, it's the Seyfert galaxies, radio galaxies, quasars, and blazars.
Yeah, and radio galaxy, I only ran across here. Everybody else just says it's Seyfert, blazars, and quasars.
Yeah, radio galaxies, 0.01% of all galaxies.
I think Freudenrich just made that up. I think he has stock in radio galaxies or something, so he slipped it in.
That's funny. Carl Seyfert coined the, obviously in 1943, the Seyfert galaxies. And what's the deal with these?
So let's see. The Seyfert galaxy has no jets.
Oh, right.
So this is the thing about an active galaxy, and this is why they think there's a supermassive black hole at the center. They think that the accretion disk of gas and dust and everything that's just swirling, circling the drain of the event horizon of the black hole.
Yeah.
As this gas and dust circles, friction develops, speed develops, and it gets so hot that some of that material doesn't get sucked into the black hole, instead gets shot away above and below the black hole
Right.
into jets that are so tall, they're as tall as the galaxy is wide. They're just huge, huge energetic fountains of just basically pure energy.
Yeah.
And that's what causes this brightness that can be seen from so far away. And depending on the angle of it relative to us,
Right.
we've basically said it's a Seyfert galaxy, which means that we're probably seeing it from the side.
Right.
And so we can't see the jets because they're not pointed to us. And then there's blazars and quasars too.
Yeah, in the case of the blazar, that's looking basically straight on at that jet that you were talking about,
Coming right at you,
right at your face.
looking down the barrel of a blazar.
And then the quasars, we discovered those in the 1960s. They've discovered, like 13,000, but they think there could be up to 100,000.
Mm-hmm.
And these are billions of light years away from us. And these are the ones that are the most energetic of them all.
Yeah. So if you look at a quasar or something like that and the jets coming out of the quasar, what you're actually seeing is basically the most potent particle accelerator in the universe.
Yeah.
Just shooting those energetic particles into space. It's amazing. I can't imagine what it would be like to be anywhere near something like that.
You'd die.
Yeah, but if you were just there in spirit or something,
Sure.
Yeah.
Or if you could see it with a space telescope.
That'd be great too. I'd settle for that, for the James Woods Space Telescope. What else you got?
Oh, the starburst galaxy thing at the end was kind of interesting.
Yeah, this I just want to go on record as saying starburst is one of the most beautiful words ever.
You like that?
I love it.
Yeah, I like that too. Attach star or burst onto anything.
Mm-hmm.
Well, that's not true, because a fecal burst.
Fecal burst.
No
or
good.
a fecal star.
That sounds prettier than fecal burst.
A fecal star, sure, I guess. Yeah. Just about everything sounds better than fecal burst.
So galaxies as we know them have a very low rate of new stars being formed, usually about one a year.
Yeah.
But these starburst galaxies produce more than 100 a year, which is amazing
Yeah, it is.
compared to the rest.
100 times more amazing than a regular galaxy.
That's true.
They also think that they burn themselves out rather quickly, and that those might actually be the globular clusters that end up just kind of hanging around a real galaxy.
Well, they say the stars that burn the brightest.
Yeah, like Jimi Hendrix.
Yeah.
The 27 Club, all globular cluster starbursts. That's it.
That's it.
If you want to know more about galaxies, friends, there is a whole universe out there for you to go check out. And you can start on the internet, so go check it out there. And since I said something weird like that, it's time for listener mail.
So in lieu of listener mail,
Oh, okay.
we got a lot of feedback on our Stalker episode, which kudos to you. That was your idea.
Oh, thanks.
And that ended up being a really good episode, I think.
Yeah.
But we got a lot of emails from both men and women who had been victims of stalking.
Some people who didn't even know they'd been stalked
Yeah.
until they listened to the episode. They're like, oh, okay, well, I was stalked.
Yeah, and some really just heartbreaking, scary, in-depth, long stories that we heard.
People who had to move, people
Yeah,
who were
man.
still in the midst of it. It's
Yeah.
just awful.
It's tough stuff. So we're not going to read any of those because they are very personal stories. And
They're all anonymous,
yeah,
rightfully so.
most of them were. But we just want to say thanks to everyone for being brave enough to share your story with us.
Yeah.
And just direct people to get help if you're being stalked. It is serious stuff, and I hope that podcast really got that across.
Yeah, and that was one thing almost universally that we heard was that, thank you for saying, go find local help because
Right.
it's out there, and that's a huge first step.
Yeah, and a lot of these people, just like we had talked about, kind of went through the verbatim steps of people at work thought I was just overreacting, and even
Right.
my family thought I was blowing it out of proportion.
Why didn't you press charges the first time? What
Right.
did you wait for? Blaming the victim, basically.
All that stuff. So you can reach out to the Stalking Resource Center, the National Center for Victims of Crime. It's a good place to start. There are plenty of, depending on what country you're from, there are different organizations. I see one from the UK where you can report a stalker. And in fact, one of our listeners from the UK had a really hard time over there being taken seriously.
Yeah.
And then there's also RAINN, RAINN, who is in their 25th year, and they have some good resources for you as well.
Yeah.
So just check it out online.
Nice work, Chuck.
Nice work, Josh.
All right. Well, thank you, everybody who wrote in. And if you want to write in for any reason, you can go to our website at stuffyoushouldknow.com and check out the social links. I have a website too, thejoshclarkway.com. And you can send us all an email, me, Chuck, Jerry, everybody, to stuffpodcast@howstuffworks.com.
For more on this and thousands of other topics, visit howstuffworks.com.
Geico presents a 30-second podcast between your podcast. Today's story is shared by one of our listeners. It's called Betrayed by Bill. It was in that moment I caught who was staring back at me in betrayal, or more like what? My insurance bill. With trembling hands, I grabbed my phone and switched to Geico, saving about $900 in the process, and never to be betrayed again. Now that was bloody riveting.
It feels good when the story ends with savings. It feels good to Geico.
You know, you could be adored by everyone and still completely ignored by your cat. Trust me, I know. But if you feed your cat Sheba, you can go from being ignored to truly adored in 12 days, guaranteed, or your money back. Sheba has a full menu of products, appetizers, entrees, treats, even a kitten's menu. It's so cute, so Sheba has a product for even the pickiest eater. Like Sheba Puree, it's made with bone broth, they're chef-inspired flavors, it's got a smooth and creamy texture that cats love, and contains no corn, wheat, soy, or artificial flavors. It's food that your cat's gonna love. To learn more, check out Sheba.com. That's SHEBA.com.
This is an iHeart podcast. Guaranteed human.